Algebra 2 review 1 through 75 for your test coming up. This would be part 2, picking up from question 13. Clearly, question number 12. Question number 13 says solve x squared plus 2x minus 12. To me, this is a simple, like, factor it down type of thing. We've got a plus and a minus, so we're going to look for things that fit into this scenario. We should have x and x. If I have plus minus, what should I have on the inside? Minus minus, somebody says. Minus minus doesn't work. Does anybody know why minus minus doesn't work? Right. Whenever I multiply those negatives, I'm going to wind up with a positive. So minus minus only works in here whenever it comes out as minus plus. Right. That's whenever I use minus minus over here. Okay. So if I have plus minus, I'm actually going to use plus and minus. Now it could be minus plus, but I need a plus and a minus. Right. Because that's the only way to multiply two things and get a negative. All right, so we know we're going to get a plus. Well, it's hate whenever I misuse my eraser here. So plus and minus. So things that multiply to be negative 12, or multiply to be 12 for that, whenever I add up the positive and negative, I'm going to get 2. What do you think? Put things multiply to be 12. 2 and 6, right? 3 and 4, okay? In any of those cases, you know, if I've got 3, if that's a 4 minus 3, that's only giving me 1, okay? 6 and 2, right? If I've got a positive 6 and I subtract 2, that's only leaving me with a 4. Am I in a situation where maybe I can't just factor this way? Yeah, what might I need to do? I might need to use the quadratic. And a good way to determine that off the bat is to, even look at it in terms of 2 squared minus 4 times 1 times negative 12. All right, well, I'm getting 2 squared is 4, right? 4, and I've got negative 4 times negative 12, right? What is that? That's 48. 4 plus 48 is what, 52? That's a positive answer, which means I should get 2 real solutions, right? But maybe they are, maybe they're decimals, maybe they're fractions, something like that. So let's break this down and let's actually do the whole thing. As a quadratic, that would be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 12. All over 2 times 1. Okay, so we know we're going to get negative 2 plus or minus, and what did we say was in here? Was it 52? Is that right? 52, square root of 52 divided by 2. Right, what we want to do from there is let's see if we can break 52 down. Would that be 2 and 26? Is that right? That's going to be 2 and 13, and we begin to see the problem that we had earlier right off the bat. Because what is radical 52 reduced to? 2 radical 13. So what I have is negative 2 plus or minus 2 radical 13 divided by 2. Right? Okay, so what's negative 2 divided by 2? Negative 1. And this would be plus or minus. What's 2 divided by 2? 1. So really that would just be plus or minus radical 13, right? What's the answer at the bottom? This, negative 1 plus or minus radical 13. Do we see now why we couldn't just factor it down and get a really easy answer? All right, so my warning to you is if it doesn't factor, don't try to force it, right? Can I always use the quadratic to solve? Sure can. Okay, so if I get stumped, let's go back and let's try something else. All right, because what I'm told is that this is our answer, correct? Now, it might have split it up. Did it say negative 1 plus radical 13 and negative 1 minus radical 13? Or just showed it like this? showed it like that. Okay. All right, do we understand the process there? Hopefully we understand our quadratic formula, how to set that up. Negative b plus or minus the square root of b squared minus ac all the way. If you don't know that, you can come around and ask me sometime about it, or you can look up the quadratic formula in your textbook, write that down, study it out a little bit. All right, let's look at question 14. Write the answer in the form a plus bi. A plus bi. All right, I'm going to go actually down to question number 14's answer key, because what's nice about this is you can look and you can see that the lesson is from lesson 62, right? So let's go over to lesson 62, right? Because sometimes we just need a refresher on what it is that we do with certain things. Lesson 62. Lesson 62 shows up on page 442. All right, starts talking about complex numbers. And what you'll see on page 443, it says add or subtract complex numbers. It actually gives me a little formula here. Okay. Okay, 1 plus 7i plus 5 minus 9i. So what they show you is a plus bi, which is this 1 plus 7i here, okay, plus c plus di, which is my 5 minus 9i, is equal to a plus c. That would be 1 plus 5. Okay, what is 1 plus 5? 6. Okay, so we've got 6. And in the next part of this, okay, we're going to do a plus c, which we did. And then we want to do b plus d. That's going to be 7i plus negative 9i. Okay, so what is 7 plus negative 9? Negative 2. Okay, so that's going to be negative 2i. Okay, so just so as a refresher, 1 plus 5, 7 plus negative 9 with the I. What was the answer? Was it 6 minus 2i? All right, there it is. All right, so I just wanted to give you an example of how can I use the answer key to help me study, right? I use the answer key to find the lesson that the question came from. As soon as I knew that, I took my textbook, I went back to that lesson, all right? I found an example, it gave me a box to look at, and then I could see the steps. Does that make sense? All right, so more than just the video of the review, you guys have an abundance of resources to use to help you study. One of those is and has always been your textbook, okay? All right, 15, we want to find the roots, which means a couple of different things. We can find the roots are where x equals 0. Okay, if I plug this in for x, it causes it to equal 0. Or in a graph, it's where it crosses the x-axis at. So we have negative 5x cubed minus 25x squared plus 40x plus 240. There is one thing that we can try to do off the beginning. Could we try to solve this by grouping? Okay, that's usually one that I like to try to start with because it's easy to determine off the beginning if it's going to work or not. In the first set of parentheses, what would you want to factor out of that? Negative 5x squared, right? What would that leave you on the inside? X plus 5. Okay, what would we want to try to factor out of 40x plus 240? We want to try to factor out the 40 because what we ultimately want, and we'll know if it works, is if I'm left with an x plus 5, right? All right, so is 240 divided by 45? No? It's 6. Okay, well then grouping didn't work here, did it? Okay? So what we have to do is try synthetic division. Okay? Find the roots, state the multiplicity of each root. Now, there is a way to at least start with synthetic division, at least start with the right number and break it down from there. Right? This is where I would use my graphing calculator, okay, to at least find one root, and then after I found one root, I can reduce it from that, okay? So I'm going to clear this out. We're going to hit y equals. We're going to start with the function, the whole thing. So negative 5x to the third minus 25x squared. plus 40x plus 240. All right, and then I'm not even going to hit second graph. I'm just going to hit second, or I'm not going to hit graph. I'm going to hit second graph. Right, and what I'm looking for is where does y equals 0 at? You notice that it equals 0 at x equals 3. So I know this for sure. I know that 3 is a root. Okay? You follow me? So what I'm going to do from now that I know that 3 is a root, I'm actually going to plug 3 into the synthetic division for it. Okay? So negative 5, negative 25, 40, and 240, and we're going to use 3 as a root. Okay? So I'm going to bring down the negative 5, I'm going to multiply by 3, I'm going to get negative 15. I'm going to add those things up. It looks like I'm going to get, what, negative 35? Okay? What's 3 times negative 35? Negative 125, is that right? Negative what? Negative, I'm sorry, negative 40. Okay, negative 40 here. All right, so 3 times negative 40 is going to be negative 120, right? Okay, what's 40 minus 120? Negative 80? Oh gosh. What's 3 times negative 80? Is that negative 240? Good. Negative 240, which means we got 0. You say, well, why did we do that if we already knew that it was going to work? Because I needed the result. Okay, the result of this is negative 5x squared minus 40x minus 80. Can anybody see anything that can be factored out of that? I could factor out negative 5, okay, leaving me with x squared plus 8, 8x. Let's see, what's negative 80 divided by negative 5? 16, positive 16, is that correct? Now, does this look like something I can factor down to this? X and x, what do you say? 4 and 4? X plus 4. And the other factor we knew we had was x what? From up here. Minus 3, right? All right. So it says find the roots, right? Our roots are 3, negative 4, and negative 4. The multiplicity of x plus 4 is 2. The multiplicity of x minus 3 is 1. Right? What's the answer say at the bottom? Somebody want to read that off to me? Okay, so we got it right? Okay, because I thought I heard 1 back there, and I wasn't sure. But you said 3, yes? Because what we're saying with this is that x equals 3, right? If I want to move it, I have to subtract it to get x minus 3. Because look at this. Looking at this, you know that x equals 3, negative 4, and negative 4, right? So 3 goes there, but as a factor, it's x minus 3. Okay? So I've undone it from here, from up here. Then that would have been a positive. Her question was, what if this had been a negative 3 up here and it had worked? It had been a positive 3 right there. Okay? It'll bear the opposite sign because it's on the other side of the equal sign from the x. Okay? Does that make sense to you? If it doesn't make sense, then you won't get it on test day. Makes sense. Okay. Okay. Let's see. 16. Okay. Find inverse sign of negative 1. Give your answer in both radians and degrees. This is something that your calculator is going to do. Inverse sign of negative 1. So how do I get inverse sign in my calculator? Second sign, negative 1. Negative 90 degrees. Okay, so we've got negative 90 degrees. Okay, now we want that as a radian. Anybody know how to do that? How do I convert degrees to radians? I will tell you, we divide by 180. Okay, what's negative 90 divided by 180? Negative 1/2, right? Okay, does anybody know what goes in the numerator when we talk about radians? What always goes in the numerator? Pi. So we're going to write that as negative pi over 2. Okay, what's the answer at the bottom of the page? Was it negative 90 and negative pi over 2? Okay, good. All right. So again, this is one of those instances where it's not going to be enough to go back and just watch the video. You're going to have to listen to it because I didn't write down the description of how to convert degrees to radians. You're going to divide by 180. All right. Write it off. It has to be written as a fraction. You cannot write it as a decimal. Okay. And pi has to go in the numerator. Okay. If you wanted to leave 1 in the numerator, you could, but you don't need to here. Okay. All right, 17. How long is side A nearest tenth of an inch? Okay. How long is side A nearest tenth of an inch? Do you have a question? No? Okay. What am I going to use? We've learned some laws. Does anyone know what law we would use here? A squared? Oh, you're thinking maybe Pythagorean theorem? Or are you thinking the law of cosines? Law of cosines. All right. In cosine, that a squared equals, but I need 2 sides. Do I have 2 sides here? No, I don't have 2 sides. So law of cosines is only going to work when we have 2 sides. But you are in the ballpark. It's not law of cosines, it's law of what? Law of what? Law of sines. All right. How many of us remember what law of sines is? Should be sine of angle A over side A equals what? Sine of what? B over side B equals sine of C over C. Now, I don't need all 3 of them, right? I'm only going to use 2 of them at a time. So let's go ahead and try to set this up here. All right. Do I know what angle A is? Sure. Okay. So what am I going to write in on the top? Sine 58. And I don't know what side A is, correct? Okay. Do I know what angle B is? It's 38. Okay. Do I know what side B is? 5. Good. Okay. All right, so I've got this proportion set up. What do I do with it? Perfect. So I'm going to rewrite that as what, Janet? Excellent. If I was going to plug all of this in my calculator at once, what would I need to do with the numerator? Parentheses around it. So I'm going to do parentheses 5 sine 58, close both sets of parentheses, and then hit divide by, and then I can just type in sine 58. I don't have to put parentheses around that. Somebody tell me what you get for an answer. 6.1? I'm sorry, I'm mostly deaf. 6.9 inches. What's the answer at the bottom? 6.9 inches. Okay. So very good. You guys pretty well. I mean, it took the whole class, but we figured out which law to use. All right. We applied it. We remembered it. We used it. You guys did pretty much all that work yourself. All right. 18. 18. Inverse. All right. Let's start off with talking about inverse. We have two rules for finding the inverse. Does anybody remember what rule number 1 is? Emily? Switch the y and the x. What's rule number 2? What's the next step? Anybody? That may take place, but in the end, I'm ultimately trying to do what? Solve for y. Okay, so if we want to find the inverse of this, we're going to start off by saying x equals the cube root of negative 6 times y minus 42, correct? All right, now you're not wrong. The first thing that we need to do is we need to get rid of this cube root symbol, correct? All right, how do I get rid of a root? By using the exponent of that root, correct? So take it to the third. So we've got x cubed equals what now? Negative 6y minus 42. Okay, now this should get fairly easy because all I want to do is solve for y. So I'm going to try to get everything away from y. We should have done this all year. What do we want to do next? Add 42. Okay, add 42. So we're going to get x cubed plus 42 equals negative 6y. Last step. Divide by negative 6. I love how in unison and cult sounding you guys are. That's perfect. All right, so we have y equals, you could write that as the negative, x cubed over 6. What's 42 divided by negative 6? Negative 7. All right. What's the answer at the bottom of the page? Is it this? All right. And they might have written it just slightly different. Tell me if I'm wrong here. Did they do negative 1/6 times x cubed minus 7? Did they write it like that? Yeah. Okay, so just be prepared that it might look like that instead. Okay? All right, that's 18. So we remember those two rules. Okay, flip the x and the y, solve for y. Percent change. So now we're kind of back, right? We're back to where we were at the beginning. Percent change from 50 to 58. All right, does anybody remember what our process is for finding this? Original, is it original minus new or new minus original? New minus original. So my new number is what? 58 minus 50 divided by what? Divided by 50. All right, so that's going to be 58 minus 50 is going to be 8. What's 8 divided by 50? What is it? 0.16, is that what you said? So equals 0.16. We want this as a percent, though. So I'm going to get 16%. Is that right? Is this increase or decrease? So they might want you to say 16% increase. What's the answer at the bottom? So it does use increase there. Okay, 16% increase. Okay? Good. All right. Let's see. 20. Classify the polynomial according to its degree and number of terms. All right. Well, what is the degree of that polynomial? Okay, we're coming back. We're hitting these same questions that we've answered. Actually tells me it's 4. So degree is being represented by this 4 or this 4. Which one? The coefficient or the exponent? The exponent. So the number of degrees is the largest exponent. So 4 is the number of degrees. How many, in number of terms, how many terms do I have? 4. Okay, 1, 2, 3, 4. What does it say at the bottom? It says, does it say quartic? It says quartic, so that's how we're classifying it, because it's got 4 quartic. And what does it say for number of terms? Does it say just 4? What's it say? That's all it says? Okay. That's all the answer to number 20 says, so it's quartic? Okay. All right, so should have 4. I was interested to see if they would maybe say 5, just because it has no constant, that it wouldn't have been out of the norm to say, plus 0 and give it 5 terms. But they just gave it as quartic, so I guess that's fine. All right, 21. F of x is 4x minus 3. G of x is negative 3x plus 7. Find f times g of x. So what am I doing with 4x minus 3 and negative 3x plus 7? Multiplying them, okay? So 4x minus 3 times negative 3x plus 7. What do we call that particular kind of multiplication? FOIL. Very good. So what's the first thing I multiply? 3x. What is that? Negative 12x squared. I love the Colt unison. Negative 12x squared. All right, what's next? 4x times 7, what's that? 28x. Good. All right, what's next? Which is positive 9x. All right, next, which is negative 21. Okay, do I need to do anything else with this? Like terms. So negative 12x squared doesn't appear to have anything. What about 28 and 9? Plus 37x minus 21. Okay, find f of g of x. Scroll down to the bottom. Do they want anything else? They like it just like that? Perfect. All right, we can scroll back on up to the top to question number 22. It says solve the system. Solve the system. We have 1/2 x equals 5y. We have negative x minus 5y equals 15. What do you want to do here? Okay, if we see this question on the test, what would you do? Substitute. Okay, so somebody say substitute. Move the 5y over. So you're going to, how would you move the 5y over? Subtract. So you're going to write that as 1/2 x minus 5y equals 0. Okay, and then you've got negative x minus 5y equals 15. And you're going to subtract, okay, because that double subtraction means you would add, and so you would be essentially doing negative 5y plus 5y, which cancel out the y's. Is that what you're doing? Yes, question? What is 5y multiplying by? 5, but we moved the whole 5y over. If I was solving for y, if she had solved for y and 1/2 x equals 5y to move that 5 over, then yeah, you would have had to have divided. But she moved the 5y, the whole thing over by subtraction. So 5y minus 5y equals 0 over there. So that's how she got 1/2 x minus 5y equals 0. Does that make sense? Okay. So you're subtracting here and eliminating this. So you're taking what, 1/2 minus 1? What's that going to be? So 3/2 x. And 0 minus 15, negative 15. So if you want to solve for x, what is it that you need to do? Divide by 2 over 3? You're really, really close. You're off by one thing. You're right that you need to use the reciprocal, but you're wrong in how you're using it. Multiply by 2/3. Okay? All right, so what's negative 15 times 2? You got the final answer. Negative 15 times 2 is negative 30. Negative 30 divided by 3 is negative 10, right? So you got x equals negative 10, right? Okay. How would we go about solving for y if I got x equals negative 10? So plug it in somewhere, right? We could plug it in up here at the top, correct? What's 1/2 times negative 10? negative 5. So you're saying negative 5 if this is negative 10. So negative 5 equals 5y. If I want to solve for y, what am I going to do? Divide by the 5, right? What's negative 5 divided by 5? Negative 1. All right, and then we could go down here and test and see if that works. This would end up being, if I plugged in negative 10 here, right, that would be positive 10, correct? And if I took negative 5 times negative 1, that would end up being positive 5. Would that equal 15? Sure. Okay, so we can get that answer. Is that the only way? Is what Geneva did the only way to solve that system? No, there's a number of different ways. But that way, did it work? Yeah. All right, so we at least want to see a way that works, and we saw that. What time do you guys get out of here early out? You guys seem to know. What? 11? Oh, 10, 11? 10, 11? Okay. All right, so what we'll do is we'll stop there.